Hello guys, welcome back to my YouTube channel. So today I'm going to present the Greencoin documentation or the Greencoin Carbon Credit Platform API documentation. So as you know, we have been working on displaying the big slides for Greencoin, and today we are just going to explain how the API documentation of this platform will gonna work. So the expected platform overview of this Greencoin project is 5,000 plus farmers in the first years or a period of 1.5 years. The amount of carbon sequestrated will be around 0.75 million tons of CO2 sequestrated, which is estimated to be $46.5 billion that is going to have a higher impact on the current economy of the carbon credit market. So the hectares enrollment is 0.12 acres million hectares of land and 75,000 output farmer payments in the first 6 months. So basically, you know how this platform just works. There is farmer registration by providing the GPS coordinates, the monitoring and verification by advanced satellite monitoring, IoT sensors, and field sampling techniques. Here, majorly in Africa, we consider the field sampling techniques by officers. So it's a first time or one time method that we're gonna use to collect this data. So looking at the token generation, the tradable carbon credits are going to be tokenized on ICP. Then the market trading will be traded externally in other platforms like Binance and other blockchain powered platforms. So the platform overview, the farmer benefits of this project is earning 15 to 50 tons of CO2 sequestrated annually per farmer. That is also bringing a higher environmental impact, social health improvement, and biodiversity. Also, the climate resilience factors considerable. So, a success story here, we find that a farmer called John Kimani from Kiambu County had an annual increase of around 35% by improving soil organic carbon and also by 2.1 over the 3 years of using cover cropping and reduced tillage practices. So as you get started by this, the farmer size, the minimum size of the acre per farmer will be 0.5 hectares, or maximum hectares will be 1,000. But we're going to reconsider using acres less than 0.5 hectares because many small scale holder farmers practice methods that are going to be sustainable. The current location that we are going to be available is Kenya, Uganda, Tanzania, and Ghana, which majorly practice agriculture at large, and also the geographical availability of this country is well suited for this project. So we're willing to take initial part in soil sampling and surveys. Therefore, the onboarding process will include an application submission, the baseline assessment, the contract agreement, the implementation support, and more. The onboarding process will typically take around 4 to 6 weeks from application to active participation. So this will ensure a crucial and accurate carbon credit calculation to avoid further problems. So the MRV methods, as we said at first, it will be a soil sampling technique which will be majorly used. So baseline, the sampling frequency will be annually monitoring for 5 years. These are quality control of 10 duplicate samples and certified reference materials. We also have the laboratory analysis, which include the soil organic carbon, the bulk density, and the pH. So another method we are going to use on this project is the biomass measurement. So the tree diameter at breast height of total height measurements of the trees are taken. Therefore, the above ground and below ground biomass calculations are going to be used to identify the amount of carbon sequestrated from the soil. So considering the cost, it is $200 to $500 per farm. So logistically, the complexity in remote areas and reserved for high value project will ensure a quick and faster verification sampling methods on this project. So the estimation, the Comet farm, as you see, the tool method using the Comet farm, whose purpose was developed by USDA to measure the model soil carbon and GHC methods, whereby it is absolutely free. Therefore, it will give an efficient time for farmers to to just locate their projects and ensure they collect the best carbon footprint sequestration in the soil.